Welcome to Chemistry with Mrs. Middle. Happy holidays and Happy New Year to all my dear AP Chem Squad. I hope you're going to enjoy the year and had lots of fun. Okay, so in chemistry, we are in Unit 5. Unit 5 is on gas laws. It is chapter 10 in your COTS book. Okay, so let's dive in. Hope you all are taking notes. Pause after some time and try to do some problems that are there for the flipped video. Okay, and make sure you take notes. If you have any questions, please ask. Unit 5 is only gas laws. There's no other chapter in this unit. So in this chapter, we are going to talk about these 8 topics. We'll learn about the experimental bias of all the gas laws, what is ideal gas laws and the chemical reactions, gas mixture and partial pressure, kinetic molecular theory of gases, diffusion and effusion, and the non-ideal behavior of the gases. Now, physical properties depend on pressure. For P, T is for temperature, and V is for volume. When we say oxygen is a gas, it means we are talking about at a standard pressure and temperature. Standard temperature is considered as 25 degrees Celsius, and the standard pressure is 1 atm. Now, the pressure is measured using a vacuum pump. The pressure can be in these different units. 1 atm is same as 14.7 pounds per pound square inch, 760 millimeters of mercury, 760 torr, or 33. This is not that much important, and 101.3 kilopascal. You have these values given to you on the back of the periodic table. Okay, so these all are different units. That is your standard pressure, and standard temperature is 25 degrees Celsius. Now, to measure temperature, we use an instrument that is called a barometer. Mercury rises up in an evacuated tube until the force of mercury equals the force of the atmosphere that is pushing up. The pressure of the atmosphere is proportional to the height of the column. So this height of the column is telling you what the pressure is. And over here is the vacuum. So this is the atmospheric pressure that is pushing the mercury down, which is resulting in mercury rising up. Therefore, the height is telling you what the atmospheric pressure is. Now, why do we use mercury as a liquid in barometer? One thing, mercury is the only liquid metal, and it is because of the density. The density of mercury is very high. So the barometer that we are going to use is going to be comparably more smaller. If we used water as our liquid in a barometer, it would be a lot more larger because of the difference in the density. Now, just what vacuum is, it was something that was discovered by the Romans, and it was believed that if there is nothing, it means it is an absence of God. Everything was connected to religion at that time. So in 1654, a vacuum pump was used, and they could not separate it even with 16 horses. So vacuum means it's absence of matter. That means there is no air present. Now let's try to understand all different gas laws, right? I'm sure there are a couple of you who love to scuba dive and you love that sport. Now, what happens to the pressure, right? So if you are at a depth of 0, or we say that it is atmospheric pressure, it is 1 atm. But since water is denser than air, for every 10 meters of depth, a diver experiences an additional 1 atm pressure. So at a depth of 20 meters, if pressure is 1 atm from air, it is going to be 2 atm from the water. Therefore, the total pressure that this scuba diver is going to experience is going to be 3 atm. So pressure under the water is much higher. This is based on the gas law, and that is your Boyle's law. Okay, so what is important, that the pressure of system of gas of particle is inversely proportional to the volume of a fixed number of moles and the constant temperature. So what is important that we are keeping the moles, which is going to be represented by N, and the temperature are constant. When these two things are not changing and we are only comparing pressure and volume, they are inversely related, which means as pressure increases, the volume will decrease. Okay. And if we call this CB is a constant, some books will call it K. It doesn't mean it is the same thing. As a result, we come up with an equation P1V1 equals P2V2. So the important thing is to remember the other two variables are constant. And as a result, when a scuba diver is deep in the water, it is important that they do not come up very quickly, because as they are coming up, the pressure is going to decrease. And if pressure is going to decrease, what will happen to the volume? Volume is going to suddenly increase, which causes bubbles. That is what is called bending and the nitrogen bubbles, and it can be very deadly. So it is based on the principle of the Boyle's law. The same thing works in a vacuum pump. So many places you're using this concept of pressure and volume. If you fly in an airplane, if you get a chance right now, I know we are not flying, you will have a bag of chips. And if you're in a plane, after it has got to a certain height, you will see that the bag of chips would get bigger, because as you go up, the pressure decreases, and as a result, volume will increase. Bicycle pump is another good example of Boyle's law. As the volume of the air trapped in the pump is reduced, when you push it down, its pressure goes up, and therefore air is pressed into the tire. So try to see the relationship of pressure and volume around you as you learn this topic. The next law is Charles' law. Again, is it important for you to know the name of the scientist associated with the law or the relationship? No, that is not important. But you should know the relationship between the variables. So what Charles' law states that volume of a system of gas particle is directly proportional to the absolute temperature when the number of moles and the pressure is constant. Now we are keeping the moles and the pressure constant, and we are only looking at the relationship between the volume and temperature. And that relationship is a direct relationship. Again, this is your constant. And if you will write this equation in terms of a constant, we come up with the equation that is V1 over T1 is equal to V2 over T2. So these are, you can consider these as your initial condition, and these are your final conditions. Okay. So what happens when you are changing one of them? So you would know three variables, you can always solve for the one unknown variable. So Charles' law is a relationship between volume and temperature, because we are keeping the pressure and the moles of the gas constant. For gas calculation, we need an absolute scale. Okay, what that means is that we cannot have a negative value, because if we have gas that is lower than 0 degrees Celsius, in Celsius, the temperature will be minus 10 degrees Celsius. Now you cannot have a negative volume or a negative pressure. So it is important that we always use a Kelvin scale. So if you know the degrees Celsius at 273.15, you will get the temperature in Kelvin. And Kelvin is an absolute scale. That means 0 Kelvin is the lowest possible temperature. And if you remember, in degrees Celsius, it is negative 273 degrees Celsius. Okay. So therefore, you will never have to deal with a negative number. So remember, this is one very common mistake that a lot of us make, is we forget to convert the temperature into Kelvin. So make sure you write this in your notes. Also, when you're converting the scale, remember the sig fix. If it is 25.0 degrees Celsius, we have to apply the addition rule. We only have one decimal place, so your final answer will only need one decimal place. We are not going to think in terms of 3 sig fix. Addition rule is least number of decimal places. If you are given Kelvin temperature and you have to convert it into degrees Celsius, it is Kelvin minus 273.15, and there is no decimal present, so the answer will only be 50 degrees Celsius. So hope this was a quick recall of sig fig rules from our unit 1. All right, Charles' law, other application is if you take balloon and you put it in liquid nitrogen, which if you see is at a very, very low temperature. So if temperature decreases, volume decreases because it's a direct relationship and the balloon will sink. Other example is you can think of a balloon on a birthday party in your basement. What happens to the on a very cold December night? The balloon becomes smaller very soon because the temperature is much lower. Now, other example that you can think of balloon, hot air balloons. How does a hot air balloon work and how does it rise up? It is also connected to a gas law that is called the Gay-Lussac law. And it also applies to the law of pressure cooker. Those of you have pressure cooker. It is a relationship between pressure and temperature. Now we are keeping moles and the volume constant. So if that is constant the same way, and remember it is a direct relationship. What that means is as pressure is going to increase, the temperature is also going to increase. So if you're looking at a pressure cooker over here, the pressure cooker has a constant volume. It has constant number of gas particles. So as the temperature increases, the pressure inside the pressure cooker rises. And if you have a pressure cooker like many Indian families, it has a whistle. And you hear that because it's the volume is constant, it's trying to release that pressure. So these are all the relationship. The important point is as you're looking at this, that understand which two variables we are keeping constant and which are the two that we are trying to compare. So now let's try to see some examples. Now, if we are not keeping any of the variable constant, the only variable we are keeping constant now is moles, which is your N. So we are assuming that the moles of gas in the container are the same. The thing that we are going to change is either pressure, volume, or the temperature. Okay, so number of moles is always given by an N. And we get this equation because we already derived that P1 V1 is equal to P2 V2 from our Boyle's law. Then we saw the relationship between pressure and temperature. We saw it is a direct relationship. Sorry, this will be P1. This is P2 over T2. And then we had also compared the relationship between volume and temperature, which was V1 over T1 equals V2 over T2. And if we combine all these laws, we get a new law that is called your combined gas law, which is P1 V1 over T1 equals P2 V2 over T2. And this is your constant. So as we are going to change these variables, this is going to change according to that. So here, what happens is, let's say you have a balloon at this temperature, this will be given to you at a pressure of 1 atm, and the size of this balloon is 10 liters. It is asking you now if the temperature, if it is at a higher altitude, the temperature is lower. We know that the pressure is going to be lower. We want to find out what the volume of the new balloon is going to be. That is going to change. You know the relationship as temperature decreases, volume decreases, as pressure decreases, volume increases, right? So, and we know our P, since we have all the variables, nothing is constant, you will get this equation if you are going to manipulate P1 over T1 equals P2 V2 over T2. You will get this equation. And then you plug in all the values that you have over here and then solve it. So I would always recommend setting up the problems, understanding the variables. Here is another problem. A sample of carbon monoxide gas occupies 3 liters. So you know that this is your volume V at a temperature of 125 degrees Celsius. So the moment you see degrees Celsius, what should come to your mind? I hope you all are thinking about Kelvin. So you will add it to 273. At what temperature will the gas occupy a volume of 1.5 liters? That means this is my V1, this is my V2 if the pressure is constant. Now, because the pressure is constant, we are comparing volume with temperature. You should be able to think about this equation, V1 over T1 equals V2 over T2, because that's a direct relationship. You solve for this variable, you identify your variables, you plug in the numbers, and you will get your final answer. Okay, so you have a couple of practice problems in your flipped video, so make sure you try some. Then here is another example. Now, argon is an inert gas used in a light bulb to retard the oxidation of the filament. A certain light bulb contains argon at 1.0 atm, and 18 degrees Celsius. Okay, so identify your variable. This is going to be my P1. This is going to be a T1. Again, degrees Celsius, make sure you're converting into Kelvin, is heated to this. So that is my T2 at a constant volume. What is the final pressure? So that means we are trying to solve for our P2. This is what is our unknown. We identified our variables. We know that the volume is constant. R is always a constant. You can also think about this as your ideal gas law. So you cancel the unit and you will end up getting P1 over T1 equals P2 over T2. This is your equation that is given. This ideal gas law is given to you on the back of your formula sheet. And then you just plug in all the numbers, make sure you've converted degrees Celsius to Kelvin, and you will get your new temperature, which is P2. So many times, many students make mistake with manipulating this and coming up with that equation. So make sure you do that carefully. Now, moles of gases, right? Moles of gas, a molar volume, 1 mole of gas will occupy 22.41 liters. But there's an important, only if the gas is at STP, and it only works for gases. STP does not apply for solids and liquids, okay? And when we say STP, that is standard temperature, is 0 degrees Celsius, which is 273 Kelvin, and the pressure is 1 atm. So if it is said that the gas is at STP, you should be able to understand that the temperature of that gas is 273 Kelvin, and you should be able to see that it is 1 atm. The pressure is going to be in the unit depending upon what pressure they are looking for. So watch out for that. So make sure you understand what that STP is. Just trying to show you the molar volume of gases at STP. It doesn't matter which gas you have. You can have chlorine, carbon dioxide, nitrogen, helium, or hydrogen. They all will occupy this same volume if the temperature is 0 degrees Celsius and the pressure is 1 atm. Okay, so they all occupy the same volume. So if the question is asking you, what is the volume in liters occupied by 49.8 grams of HCl at STP, this is the first thing you should be able to think immediately, right? So the temperature is not given directly, and this is the pressure. If they're not specified, you can use any unit of pressure. Now you know that you have 49.8 grams, so you should be able to think about that you can convert the grams into moles. So you know the moles. We know our ideal gas law is PV equals nRT. Or we can also use 1 mole is 22.4 liters. Okay, but then you plug in this equation, you know all your variables, you solve for V, and you will get the volume as 30.7. I want you all to pause this and try to do this problem by yourself. Now, rules for ideal gas law calculations. Remember, always convert the temperature to Kelvin. Convert from grams to moles if it is necessary, right? In the previous problem, it is given in grams. Make sure you convert that into moles, because in gas laws, PV equals nRT, N is your moles. And make sure you use the correct value of R. If you're using the value, the most common one that I would say is 0.0821, in which the pressure is in atm. Okay, so just you have to memorize one value of R, and that is given to you on the back. If the pressure is given to you in any other unit other than atm, just convert the pressure into atm using dimension analysis. Okay, so you do not have to worry about memorizing all the values of R. Types of ideal gas law problems. Determine one unknown quantity of gas variable. So out of PV and RT, one of them is going to be unknown. Make sure you understand the relationship if it's a direct or an indirect. We'll have stoichiometry problems, and we will have the gas density problems. So we are going to work on these different types of problems as we are going to try to understand the gas laws. We'll work on this in our next video. For now, this is good. All right. If you have any questions, make sure you write them down and ask me in class.